So we're going to solve radical equations today, and the key thing to remember is to always check for extraneous solutions. That means when you get your answer, make sure you go plug it back in and verify that it actually is a true solution. So let's start with the basic one. Let's take the cube root of 2x plus 7. We're going to set that equal to 3. Now, we have to use whatever power will undo this. If we think about this as to the 1/3 power, or even considering a basic cube root, the power that undoes a cube root is a cube. So I cube both sides. I get 2x plus 7. 3 to the 3rd power is 27. And then I go on and solve for x. Now I need to take this and verify it. So I'm going to plug it into the original equation, which had a cube root of 2 times whatever the x value was, plus 7, and we want to know if that is indeed equal to 3. So if I type that into my calculator, and just make sure that everything works out, 2 times 10 plus 3, make sure you type in the correct thing. Should be a 7. And that gives us the 3. So this one worked out. So we know that it is true. So this is a true solution. Let's try another one. Let's try the problem x plus 1 is equal to the square root of 7x plus 15. Now, since it's a square root, we will square both sides to eliminate the root. When I square both sides, on the right, it's straightforward. But on the left, I have to write it out twice, right? We know this is x plus 1 times x plus 1. And then we have to FOIL it. If I do that, I end up with x squared plus 2x plus 1, and then I can solve the equation from there. I'm going to move that 7x to the other side. I'm going to subtract the 15, get everything equal to 0, and then I'm going to have a basic quadratic equation, which I can probably factor. If you couldn't factor, you could try the quadratic formula at this point, but let's try factoring. What numbers multiply to negative 14, but add up to negative 5? It's going to be a 7, and a 2, and the negative will have to be on the 7, positive on the 2. Now the solutions that these result in are x equal to positive 7 and x equal to negative 2. Now we need to test each one. So first thing I'm going to test is that positive 7. When I test the 7, plugging it into that original equation, it was x plus 1 equal to that root. When I plug in the 7 plus 1, I want to know, is that in fact equal to the root of 7 times 7 plus 15? So I know this side is 8, so I'm going to plug in this side. The square root of 7 times 7 plus 15, that gave me 8. So I get 8 equal to 8. That is a true statement, so I know that this is a true solution. Now let's test the other value. Let's test that value of negative 2. Is negative 2 plus 1 equal to the square root of 7 times negative 2 plus 15? Well, let's check. On this side, on the left, I know that it's going to be equal to negative 1. I need to know the value of this. 7 times negative 2 plus 15, and that gave me positive 1. Is negative 1 equal to positive 1? No. So the result is that negative 2 is not a solution. and that means it is an extraneous solution. So in my answer, I would cross out that because it is extraneous, it does not apply. 7 is the only real solution. Let's do an example where the root is not written as a root, it's written as a rational exponent, and then maybe, see if we have time for one more. Let's take the equation x plus 2 to the 3/4 power minus 1 is equal to 7. Just like when you're dealing with a root, when you're dealing with a rational exponent, your goal is to isolate the root or the thing with the exponent. So our goal is to isolate this piece that has that rational exponent. I'm going to move the 1 to the other side. Now, when I look at this, I need to ask myself, what could I raise each side to so that this exponent would then disappear? So if this exponent effectively disappears, that means it would have an exponent of 1. So think about if I have 3/4, 3/4 times what fraction makes 1? 3/4 times something makes 1. Well, that something is going to have to be that reciprocal, because if I have 4/3, right, then I'd get 12 divided by 12, which is just 1. So that means I'm going to take each side to that reciprocal power. I'm going to write it here just so we know what the original was and then what the next step is. So raising each side to the 4/3 power, and we end up here with x plus 2, because these cancel out. 12 divided by 12 is 1, x plus 2 to the first power is just x plus 2. And then 8 to the 4/3 power is going to be 16. You could type this in your calculator so that you could check it and know, but cube root of 8 is 2, 2 to the 4th is 16. Subtract your 2, we end up with an x value equal to positive 14. Now we need to go back and check it, because even though this isn't written with a root, we know that it effectively is a root because it's got a fractional exponent involved. So checking the 14, 14 plus 2 to the power 3/4 minus 1, I want to know, is that equal to 7? Let's just use the calculator and simplify it at this point. We should be able to do it in our heads, but just to be sure. 14 plus 2, close parentheses, to the power 3 divided by 4, 3 divided by 4, in parentheses, making sure it does what I want. Minus 1, is that equal to 7? It is, so that means that this is a true statement, which means this is a true solution. So there's a few other problems in your book, and after this one, and I've just been doing these examples from the book, I want you to look at example 6 on page 455. If you look at example 6 on page 455, it will give you a more complicated example that is similar to these. The take-home point is always remember to check for extraneous solutions, because these are fairly simple problems, but sometimes there's things that don't actually work out. Thanks.